At this stage, we know how to indicate different positions in the statistical series, like here. First 25% of the population, first 50% of the population, or here the last 25% of the population. We know how to compute and interpret the median and the quartiles. The median is the middle value. It divides the population into two halves, and the first half of the population is characterized by the variable value not lower than the not higher than the median, and the last 50% of the population is characterized by the variable value not lower than the median. We know also how to compute for the first and the third quartile. Here we have the first quartile group, first 25% of the population, first 25% of the lowest values in the statistical series. And we know that these 25% of the values are not greater than the first quartile. We can also indicate the last 25% of the highest values, and we know that these values are not lower than the third quartile. We also know that the second quartile means the same like the median. And now we are able to expand our analysis with another quintiles, in which we have quintiles, deciles, and percentiles. Quintiles can be associated with quint. It means 5 pieces, yeah? So we divide something by 5. We have 4 quintiles and 5 quintile groups. First quintile means 1/5, 20% of the population. First quintile determine the first 20% of the lowest values, which are characterized by the variable value not greater than first quintile. The second quintile divides the population into 2 parts. The first 40% of the population and the last 60% of the population. Second quintile interpretation is following. 40% of the population is characterized by the variable value not greater than the second quintile, and simultaneously 60% of the population is characterized by the variable value not lower than the second quartile. The most interesting quintile is the last quintile, and actually the first quintile. The last quintile indicates us the highest 20% of the values in the statistical series. These values are not lower than the last quintile. The next group of measures are deciles. Deciles can be associated with dividing something by 10. We have 9 deciles and 10 decile groups. First decile indicates us 10% of the lowest values. So this is actually the margin group, yeah? The margin group of the lowest values in the statistical series. 10% of the population here is characterized by the variable value not greater than the first decile. So in point of view, for example, the monthly incomes, here we have the poorest employees, yeah? The poorest employees, the lowest monthly salaries. Here we have the last decile, and the last decile indicates us the group of 10% of the highest values in the statistical series. So this 10% of the values are not lower than the ninth decile. These measures, like deciles and percentiles, are useful in indicated in the indication of the margin groups and in pointing out the differentiation in the statistical series. If the differentiation, the variation of the values are relatively small, the difference between first decile and the last decile are quite small. If we have high differences in example in the monthly salaries, yeah, the difference between the ninth and the first decile is quite high. Yeah, the difference between these two measures is quite high. So we talk about the huge differentiation in the data set. So actually this is the introduction to the next topic, the measures of dispersion. We will talk about it later. And the last group, we have the percentiles. Percent means dividing something per 100, yeah? We have 99 percentiles and 100 percentile groups. It means that we are very flexible in the indication of the position in the statistical series. We have 99 measures here to utilize. And first percentiles indicates 1% of the smallest values, and these values are not greater than the first percentile. So here we can indicate, we can show the extreme margin groups of the extreme highest and the extreme lowest values in the statistical series. Here we have the formulas. They seem to be difficult, but actually in the formulas only two parts change. The symbol of the measure and the fraction here. If we talk about the frequencies, if we perform on the frequencies, if we perform on the relative frequencies, the same thing, we change the symbol of the measure and a fraction here. And that's all. First, we have quintiles. As I said before, we have 4 quintiles and 5 quintile groups. So from I equal 1 up to 4, we indicate, we compute respectively the next quintiles. First quintile, it's 1/5, yeah, 20% of the population size increased by 1. The second quintile means here 2/5, 40%, yeah, of the population size rise by 1, and so on The same thing here, maybe third quintile means here 60%, because I insert here 3 value. And the last quintile is the fourth quintile. Here I put 4, and here I have 4. Fourth quintile means 80%, so I can indicate the last 20% of the population, which is characterized by the highest values, but not lower than the fourth quintile. The same thing here, we have 9 deciles, and if we want to compute the first decile, we take 1 here, and we also insert 1 here, and as you can see, I have here 1/10. Yeah, 1/10 means 10%. 10% of the population size raised by 1. If I want to compute the last decile is 9th decile. 9th decile means 9 divided by 10. Decile, this prefix means to divide by 10. So here I have 9/10. Yeah, if we want to compute the last decile. And so on, the same thing, the analogous thing we have here. If we want to compute any percentile, we can indicate any position, whatever position we want in the statistical series. So this measure is very flexible because we have 99 positions to choose. So we are very flexible, and we can choose between 99 different positions in the statistical series. All right, so let's compute some tasks. Finally, here we have the penultimate task in this section. Data concerning the employees of business and finance management company according to their sex and their weekly time spent at the computer is presented in the table below. And here we have our variable and its intervals of values, time spent at the computer, and here we have the information about the number of men and their time spent on computer, and the percentage of women and their intervals of time spent on computer. So we have 2 different groups and 1 variable, and we have to solve the following problems. First 3 problems are dedicated especially for you because you know how to do it. First, compute and interpret median of the variable values for men and women. It means the median of time spent at the computer for the group of women and group of men. The second one is to try to analyze the weekly time spent at the computer of 25% of men and 25% of women who spend the least or the most time in the front of the computer. So here you have been asked to find first and the third quartile for women and men. Yeah? Here we have the group of 25% of men or women who spend the least time in the computer. Here we have the group of women or men who spend the most time in the front of the computer. And please compute these 4 measures of position: 2 first quartiles and 2 third quintiles for respectively the group of women and the group of men. And the last one, calculate and compare mode and mean amount of time that employees spend per week at the computer, of course for men and women in business and finance management company. Mode and arithmetic mean. It's very simple. I know that you will do it perfect. Alright, but my task is to wait a second. My task is to compare the weekly time spent at the computer of 20% of men and 20% of women who spend the least or the most time in the front of the computer. Hence, this is our current topic. We should utilize here the measures of what? The measures of position and especially quintiles, because we are talking about 20% of women and men who spend the least or the most time in the front of the computer. So we need first quintile and the last quintile, which is the 4th quintile in this interval series, in order to indicate mentioned before groups. Yeah, we need first and the last quintile for women and men. We can start our analysis with the group of male employees. First of all, so at the moment we don't care about the woman. We deal with the frequency of men. First of all, here we have the frequencies. We need cumulative frequencies. The column of cumulative frequencies is necessary here. Maybe here we have N, I, M, subscript M means men. Here we have N, I, S with M subscript, cumulative frequencies. The first cumulative frequency is the same as first frequency, 6. 6 plus 13 gives us the second cumulative frequency, which is 19. 19 plus 11, 30, 30 plus 31, 61, and 61 plus 39, of course, it's what? 100. This is also the population size, population of men employees. Okay, so it's not a problem to indicate 20% and 80% of the population. 20% of the population will be, of course, obviously 20 people. Yeah, because the population size is 100, so 20% of the population is 20. And we want to find the first quintile, which indicates the group of 20% of men who spend the least time in the front of the computer. x0 plus 1/5 n plus 1 population size raised by 1 minus n s minus 1. You know, the cumulative frequency from the previous class that precedes the class of the first quintile, n0 and c0. Okay, so in which of the class we exceed 20% of the population for the first time, if we assume that we are going down from the top to the bottom. Here, yeah, 19 is not higher than 20, 30 is higher than 20. So here we have K1 for men, first quintile of men. And now we are able to make some computations. Lower bound of that class is 11 plus 1/5 multiplied by 101. Yes, because this is the population size increased by 1. Minus cumulative frequency from the previous class. I remind you that here we have the 0 level, so here we have the -1 level. Cumulative frequency from the -1 level is 19. This nominator is divided by n0, and 0 here is 11. Multiplied by the range of that class, the difference between the upper and the lower bound of the class, 4. And please take your calculators and make an appropriate computation. 101 divided by 5 minus 19 divided by 11 plus multiplied by 4 plus 11, it's approximately 11.436 hours per week. This is the first quintile of time spent at the computer for men. What does it mean? It means that 20% of male employees are characterized by time, by amount of time spent at computer not greater than around 11.4 hours per week. This is the interpretation of this amount. Or 20% of men who spend the least time in front of the computer are characterized by the variable value not greater than 11.4 hours per week. All right. we can also find the last quintile, which is the fourth quintile. We need 80% of the population. Obviously, it is determined by 80 people. And the last quintile is expressed by the formula as I said before. Here the only change here is the fraction and the symbol of the measure. And now we are looking for the class in which we exceed the cumulative frequency, in which the cumulative frequency exceeds 80% of the population, or simply 80 units. This situation we meet in the last class. So the last class is the class of fourth quintile. This is our 0 level, this is our -1 level, and we are able to make an appropriate computation. The lower bound of this class is 26 plus 4/5 multiplied by 101 minus cumulative frequency from the previous class, 61, divided by here we have what? Frequency from exactly the class of the fourth quintile, 39. And after that we have the range of the class. The range of the class, this is the difference between 35 and 26. It's 9. And the final result is 101 multiplied by 4/5 minus 61 divided by 39 multiplied by 9 and plus 26. The final result is 30.569 hours per week. So it means that the group of 20% of men who spend the most time in front of the computer are characterized by the appropriate amount of time not lower than about 30.6 hours per week. This is the interpretation of this measure. Okay, we can do the same thing on the basis on the data that concerning the percentage of women. If we perform on the percentages, the whole process is very similar to the previous one. First step is to compute the cumulative relative frequencies. Of course, for the group of women, first is 0.149, and now I need a cheat sheet, and the next cumulative frequencies are 0.287, 0.437, 0.775, and of course 1. Okay, and let's find the first quintile for women. We're talking about the time spent in the front of computer in the group of women workers, women employees. Okay, and we have what? First, we should determine the class of first quintile in the group of women. So we are looking for the class in which cumulative relative frequency exceeds 20% for the first time. This is the second class, K1 with W letter. Yes, it indicates us the group of women. So here we have 0 level, here we have -1 level, and the formula is following: x0 plus 0.2 minus fs minus 1 divided by f0 multiplied by c0. In our example, we have following categories: 6 plus 0.2 minus the first cumulative relative frequency 0.149 divided by 0.138. This is the percentage of women from the second class, the class of the first quintile, and C0 range of that class yields 4. Alright, and the final result is, you can check it out, 7.478 hours per week. And the interpretation of that amount is following: 20% of the population of women spend their time, weekly time, at in the front of the computer not greater than 7.5 hours per week, or 20% of women who spend the least time in front of the computer are characterized by the amount of time not greater than 7.5 hours per week. Another measure, the fourth quintile of time spending in front of the computer for the group of women, is x0 plus 0.8, because we are talking about fourth quintile, 80% minus fs minus 1 divided by relative frequency of the class of fourth quintile multiplied by C0. Here we are looking for the class in which we have the value greater than 0.8 for the first time. And that actually happened in the last class. This is the class of fourth quintile for the group of women. So here we have 0 level, here we have -1 level. The computation is following. Here we have what? 26 plus 0.8 minus the cumulative relative frequency from the previous class, 0.775 divided by 0.225. This is the relative frequency from the last class, multiplied by this difference is equal to 9. And the final result is wait a second please. Exactly, you can check it up, exactly 27 hours per week. And the main conclusion is that 20% of women who spend the most time in front of the computer are characterized by the amount of time in front of computer not lower than 27 hours. Yeah, here we have 27 hours for the fourth quintile of time spending at the computer. Okay, so this is for women, fourth quintile, and the first quintile is about 7.5. Yeah, here we have the first and the last 20% of the population. If we look at the group of men, the previous computations, we see that the last quintile, K4, is at the level of 30.6, yeah, and the first quintile is set at the level of 11.4. Yeah, so we can compare this margin measures, and we are 100% sure that in general men spend more time in front of the computer than women in this film, because all these measures concerning the group of men are higher than the appropriate measure, respectively measure for the group of women. Alright, the last comment says that we should compute the first and the last decile, the first and the 9th decile for the group of men and women. Let's start with the group of men. The first decile in the group of men is x0 plus 1/10 multiplied by n plus 1 minus cumulative frequency from the previous class divided by frequency from 0 level class multiplied by C0, the range of the class. In our example, first decile is placed in that class where we have cumulative frequency higher than 10. Yes, because 10% of the population is simply 10. It happens in the second class. So 0 level is placed in the second class, and we have 6 plus 1/10 multiplied by 101 minus 6, the cumulative frequency from the previous level, divided by 13 multiplied by C0, which is 4. And the final result is dear friends, 7.262 hours per week. The interpretation is following 10% of male employees who spend the least time in front of the computer spend not more than about 7 hours per week in front of the computer. The last decile is the ninth decile, yeah. It's hard in pronunciation. The last decile. So we are looking for the class in which we exceed 90 for the first time. Of course, it happens in the last class, is the class of 9th decile. We change the 0 level, and now x0 is 26. Yeah, this is a shortcut, but you know where these numbers come from. 26 plus 9/10 multiplied by 101 minus 61 divided by 39 multiplied by the range of the class is 9, and the final result is 32.9, exactly 32.9 hours per week. So here we have indicated the most extreme groups. The most extreme group, 10% of men who spend the most time in front of the computer, yeah. And we see that these men are characterized by the time spent in front of the computer, not lower than 32.9 hours per week. Yeah. All right. And then we can talk about the deciles for the group of women. First decile in the group of women is determined by the formula x0 plus 10% minus f minus fs minus 1 cumulative relative frequency from the previous class, f0 relative frequency from the class of first decile multiplied by c0. In our example, we are looking for the class of first decile in women group, in which we exceed 10% for the first time. It happens in the first class. So this is interesting situation. We have found ourselves in this kind of situation for the first time. So here we have the first decile for women, D1 with the W sign, and what we have here, x0, here we have the 0 level, x0 is simply 0, plus 10% minus, and how about the cumulative relative frequency from the previous class, in the situation when we don't have any previous class, yeah? So it is equal to 0 because there is no previous class. Minus 0 divided by f0 is 0.149 multiplied by the range of that class is 5. So take the calculator, 0.1 divided by 0.149 multiplied by 5 gives us 3.356 hours per week. This number is significantly lower than this number, yeah? So we confirm once again that in general men spend more time in front of the computer than women, and we can interpret this amount. 10% of women who spend the least time in front of the computer are characterized by the variable value not greater than about 3.4 hours per week. All right, and the last one, finally. Yes, I know this example is very boring, but we should know how to compute all the measures of position. Here we have what? 9th decile. So we are looking for the class in which we exceed 90% with our cumulative relative frequencies. This is the last class, of course, because 1 is only number that is greater than 0.9. So our new 0 level is here, 26. As you can notice, yes, I'm investigating the extreme groups, so I'm jumping from the first class to the last class. Yes, it's normal situation, yeah. Because I'm talking about the extreme groups, the groups which are characterized by extreme small or extreme high values. 26 plus, and here we have 0.9 minus 0.775 divided by 0.225 multiplied by 9. And finally, fortunately, we have approached to the final result in this task, and the result is equal to 31 hours per week. 31 hours per week. So in this extreme group of 10% of women, this woman spent time in front of the computer, which is not lower than 31 hours per week. But men are characterized by the highest measure of 9th decile. So once again we confirm that men spend generally more time in front of the computer in business and finance management company. And finally, the last task in the section of non-classical measures of position. Here we have a simple example of San Escobar country, and we know the distribution of monthly incomes in this fake state. The monthly incomes of the population are presented in the table below, where Ni indicates the number of statistical units belonging to ith class of income. It is expressed in thousands of units. Okay, we will make it. Compute the first and the last decile of the monthly income. Compute the poverty line in this fake state using the 5th percentile. And answer the question, what is the income of the top 5% of the most lucrative households? So we investigate the households and their monthly incomes. We are looking for the poverty line. We are looking for the most lucrative households. Yeah, we are talking about the inequality in monthly incomes. So, in my opinion, it's very interesting topic. Economic topic, of course. So let's start. First, compute the first and the last decile of monthly income. As earlier, in the first step, we need cumulative frequency in thousands. The cumulative frequency, which is 95. The next one is 95 plus 165, 260. Here we have 390 plus 77. It will be 467. 467 plus 80 is 547, and of course we can check it out. The last one is 650, and this is the sum of that column. Here we talk about the population size as well, which is 650,000 households. Yeah, in thousands households. This is our population size. We are looking for the first and the last decile. So we need 10% of the population and 90% of the population. First 10% of the population is of course 65,000. Yeah? 90% of the population is 650 minus 65. Yeah, simple arithmetics. And this is 585,000 people, households. All right. Alright. And now we are able to compute the first and the last decile, but first let's find the appropriate classes for both categories. First decile is placed in that class where we exceed 65 for the first time. Here at the beginning we exceed for the first time 65, so this class is the class of first decile of monthly incomes in San Escobar. Okay, and the last one will be placed, the last measure decile will be placed in the last class, of course, because in the last class, for the first time, our cumulative frequency is higher than 585. Alright. So first decile is determined by the formula x0 plus first decile 1/10, 10%, 1/10. Population size increased by 1 minus ns minus 1. You know what I mean, you know this category. And 0 multiplied by C0. In our example, we have what? 0 is the lower bound of the class, plus 1/10 multiplied by 651 minus 0, because there is no the previous class, and we divided this amount by n0, which is 95, and we multiply this fraction by the difference between 1000 and 0. It's of course 1000. I remind you that monthly incomes are expressed in Escobarian peso, and we make some computations. Divided by 95 multiplied by 1000, and the final result is 685.26 peso. Yeah, this is the income that characterize 10% of the poorest households. Their incomes do not exceed 685.26 peso. This is the interpretation. Please write it down. So 10% of households are characterized by the monthly income not greater than 685.26 pesos. Alright. And now we are able to compute the last decile. We know that the last decile is placed in the last class, and the formula is following: x0 plus 9/10 multiplied by n plus 1 minus ns minus 1 by over n0 multiplied by c0. And we should insert the appropriate categories into our formula. Here we have 0 level. The lower bound of that class is 8001 plus 9/10 multiplied by 651 minus here exists the previous class, and the value from the previous class, the value of cumulative frequency is 547 divided by by 103. All right, and we multiply this amount by the difference between 12,000 and 8,001, which is 3,999. All right, and the final result, yeah, I'm using a cheat sheet, is 9,511.3 pesos. So here we see a huge differences between these two values, yeah. So we expect that the differentiation of the monthly incomes in this San Escobar country, yeah, maybe it's a Central American country, yes, the differences in monthly wages are high, yeah. All right, so we know that 10% of the 10%. This is an interpretation. Please write it down. 10% of the most lucrative households achieve monthly incomes not lower than 9,511 pesos. Yeah? All right. So we have done the first command. In the second command, we should indicate the poverty line, the 5% of the poorest households in San Escobar country. In the first step, we need to know where is the fifth percentile placed, in which class. We know that the first decile is placed in the first class, and we know that fifth percentile is for sure not greater than the first decile. Yeah, we know that from this graph. Yeah, we know that here we have the fifth percentile. We know that first decile is for sure equal or greater than the fifth percentile. So from this reason, we know for sure that fifth percentile is placed in the same class. But of course, we can compute, we can make some proper computations that indicates us the class of the fifth percentile. So we divide the population size, we multiply the population size by 5%, yeah, and the result is 65 divided by 2, 32.5, and of course we exceed this amount in the first class. Alright, so the fifth percentile is x0 plus fifth percentile means 5 divided by 100. Yeah, 5 divided by 100, n plus 1 minus ns minus 1 divided by n0 multiplied by c0. In our example, 0 plus 5 divided by 100 multiplied by 651 minus 0, of course, because we are here in the first class. There is no minus 1 level. 95 is the frequency from the class of fifth percentile multiplied by 1000, and the puberty line. This is the interpretation of fifth percentile. We can perceive fifth percentile as the puberty line, and this is how many? Fifth percentile 342.63 pesos. So the puberty line in San Escobar is established at the level of 343 peso, around 343 pesos. Yeah. All right. And the last one, fourth comment is for you: monthly, mean monthly incomes and median monthly incomes. My last task is to compute the income of the top of 5% of the most lucrative households. 5% of the most lucrative. It means that here we have the 5% of the most lucrative households, and here we have 95% of the rest of the households. So here I'm obligated to compute 95th percentile. 95th percentile is of course placed in the last class. We can compute that in this way, but we are 100% sure that this measure is placed in the last class. We know it from the theory, and as I have marked earlier, we investigate here the most extreme groups. Yeah, so we perform in the last and in the first class when we have extreme small and extreme high values. Here we have 8,001 plus 95%, yes, 95/100ths multiplied by 651 minus the cumulative frequency from the previous class, divided by how many? By 103 multiplied by 3999, and the final conclusion is the most lucrative households are characterized by the value of monthly incomes equal or greater than 10,775.06 pesos. So 5% of the most of the richest households in San Escobar are characterized by the value of monthly incomes not lower than 10,775 pesos. All right. My answers are correct, so everything went fine. Of course, I have prepared you some homeworks. Among the group of homeworks, here you have a summary task in which you have to compute all the categories, all the classical measures of position and all known non-classical measures of position. So I'm deleting the content and say bye-bye.